Okay, so now we're gonna switch to 3D and the overall 3D pipeline. So we've done all this, and now we're here. So I'm gonna create a new base and call it, I don't know, 3D pipeline. So now for people who are less familiar with TouchDesigner, I'm going to create all the operators necessary to render 3D objects. So the first one, in comp, I'm going to create a camera. And then, still in comp, I'm going to create a light. Then, still in comp, I'm going to create a geometry. So by default, it's going to be a torus. And then in top, I'm going to create a render. And so by default, the geo have like kind of, there's no material assigned, but it has a kind of default Phong shader. And now I'm going to create a GLSL Mat. So people who are on older version, I don't know if it always comes with these three elements. Can anyone confirm? Do you still, does everyone see these three elements? No? Okay, if
version, I'm getting all three of those. Is that what you mean?
Yeah, but like people on older version, I think it comes naked, like without the pre-created text stats. So it's no big deal. I think this is just to kind of explain things. But if you're wondering, in the latest build of Touch, when you create an empty GLSL mat, you're gonna get the text for the Vertex Shader, the text for the Pixel Shader, and info dat. And that's where they go. Vertex Shader, Pixel Shader. So the one that gets created is pretty simple. It doesn't do lighting, that's why it's all white. So if I assign it to the Geo1, so I'm going to drag and drop it on material. So you can see now the render is white.
I'm sorry, which top did you use to create the GLSL?
I used, it's a mat. It's in the mat tab. Yeah, the other way to do it, just bear with me, I'll show it just after. So now this is like the render of the 3D scene. Actually, for this one, we don't need the light. One thing I like to do is to create a comp null and parent the camera to it. I'm gonna rename it cam parent, and I'm gonna create another null, which I'm gonna call. So these are null comps, not null tops or chops. These are like 3D objects. And this one I'm gonna call it cam target. And the cam parent, the camera one is gonna So in the look at field, I'm going to drag the cam target. And what this allows me to do is now I can move the camera up a little. So yeah, I'm just doing 4.5, 4.5. So just to like see my torus a little better.
Can I ask you to like just review the wiring it all together?
Yeah. So the cam parent is parented to the cam one.
Where is that connection defined?
It's here. And the cam one in the look at parameters as the cam target. So what I like to do is to split the view to show the geometry viewer. So you do this with pen layout at the top, and you choose the second one. And then the pen type arrow, you can select geometry viewer. And this takes a bit of views, but if you right click, you can kind of pan around. And if you middle click, you can zoom in and out. Middle click.
Oh, okay. I was about
If you
to
get
say.
lost, press H.
Yeah.
Oh, it's a whole new.
If you get lost, press H. Press Shift H. So H is gonna center the whole scene. Shift H is gonna center on the origin. But so my little camera rig it just allows me to kind of rotate the camera around the scene, and also the look at allows me to like have the camera kind of move up and down.
But you didn't add the. You changed your geo name to camera target. Is that what it is? Or?
I did.
Okay.
Yeah.
I thought that was. Oh, so you just sent the null.
Yeah.
The geo is now a null. Is that what it is?
No. It's a new null. It's a different
new
null. I still have the geo one.
Oh, okay. I don't understand why you have that camera target.
Yeah, that's what I was wondering what
So if I don't have the camera target, so I'm gonna remove it, and I move the camera up, then the camera doesn't look at the torus anymore.
Oh, okay.
That's what the camera target does. It just keeps the orientation pointing towards the center, towards the target.
Yeah, but if the target is a null, then.
Well, but it's in the center.
Oh, okay. That's why I was like.
Because so my camera target is also a geometry. So if I move it up, you can see my camera now is like.
Okay. That makes a lot more sense.
But you can make it look at the geometry too.
I could make it look at the geometry. That's true. But I'm gonna move the geometry. So. Anyway, yeah, I think. Yeah, this stuff can be like a personal preference, like whatever like makes sense for you. How you animate the camera is doesn't.
The camera parent?
So for the torus, it doesn't matter, but it's like if I add a cube or like anything that's like not something symmetrical from all sides, then it's makes it easy to kind of do like a nice kind of turntable animation. Because I'm animating the parent, which is centered, and so it like rotates my camera.
And if you did that with a camera, it wouldn't do the same effect?
Well, if I wanted to, okay, if I unparent this and I rotate the camera, all it's going to do is like, well, it's not going to do anything because the camera orientation is controlled by the look at. But if I didn't have the look at and I rotate the camera, it just rotates the camera on itself. It doesn't rotate it. So that's not what I want either.
So it's these two nulls are essentially to get
It's
the
just
camera to behave the way you want it to
yeah,
around your object
Yeah.
instead of around itself.
exactly.
Gotcha.
Yeah,
So
maybe.
So the camera parent and the camera target are both camera like operations.
Yeah, they're like controls.
They're no.
Not controls, but
So they're just 3D objects, which have like a position in space.
Is the same
And
OP the camera parent as the camera? Is it a camera?
they're both nulls. They're
Oh.
both yeah. So it's just something that is just a
point.
position to
Yeah.
in space. It's just a position in space.
Is this not showing this?
Yeah. So a couple notes on why is my geometry not showing. So you see there are this little blue dot and this little purple dot. So render is only going to render geometry, which are the purple dots on. So there is this. But also, when you go inside, it's only going to render the sub, which has the purple dot on. So if I turn this one, here it's on, but it doesn't show up because I need it here too. And I connected a null so I could like switch between the torus. And I deactivated the render and display on both. And the blue dot, it's only for the geometry viewer, but it doesn't impact the render. So if I turn off the blue dot, it's gonna go away in the viewer, but not here.
And how did you connect GLSL to the render or the
Um, And if you miss the step where I assign the material, it's on the geometry one, the geo1, the render tab. And the material you can drag and drop. Yeah. So yeah, so there's like a few things to be aware of. Okay.
Question for you, just to wrap this up. If you were to move the geometry somewhere, it wouldn't look at that.
No,
It would look at wherever those
the
points are.
null is, yeah, I'm gonna do it right now. So I move the cube, and you can see the camera still looks in the center. Yeah. You could also use directly the Geo1, and the camera could look at it,
Right.
and then it would like move with it.
The camera would move with
Yeah.
the geometry.
Yeah. Just the orientation.
Right.
Okay, so now let's look at the vertex shader. So what the vertex shader does, so I'm gonna go back to the torus quickly. Okay. So I just hit W in the viewer to kind of show the wireframe of the mesh. And so what the vertex shader does is for each vertex of the mesh, which are like, so all the points that are connected, it's going to do geometry transformations. So first it's going to do kind of word transformation. So you have, so when you create or load a 3D object, it's what is called model space. So kind of all the point coordinates are referenced towards the origin. But then if you move the whole object, then that's going to be called word space. And so it's going to take the model space coordinates and transform them with the transformation you want. So in Touch, it's so if I change the translate here and you see it's moving my torus. So this is word space. So that's happening. Just to explain a little better. Okay, I'm going to go back to the cube, and I'm going to drop an info dat no, it's not an info dat. It's sub2. Yep. So P0, P1, P2, it's the XYZ coordinate for my point. And you can see it's, so if I like put it back to 0, so you can see it's minus 0.5, minus 0.5, minus 0.5, so on and so forth. And now if I move it here, so the geometry that's stored on the CPU, it doesn't change, it's still the same. But then the GPU is going to transform the position in world space using these parameters. And so this happens, so it happens in the TDD Form function. So if I comment this line out, and I just say, so P is what comes from the SOP, and it's just the model space coordinate. And so if I just do vec for P1, so I'm not going to explain it for now, but P is a vector 3 because it's XYZ, and world space position expects vector 4. And the fourth coordinate has to do with homogeneous transformation and other things. So, but if I do this, and so now I'm not doing the TDD form. So now you can see that when I translate it, the render doesn't update. And here it does because, yeah. So when you're W, it's a default shader, and it's not using the code. So when I unpress W, you can see now the translate don't do anything because I'm bypassing this operation, which is the operation that transforms the geometry using these coordinates. So yeah, it's you kind of have to. It's gonna come in handy later to kind of understand these different spaces. And then the other thing that the Vertex Shader does is going to transform. So what is going on in the TD world to proj? So it's TD world space to projection space. An intermediate step which is not shown is camera space. And so camera space is kind of converting the coordinates into the camera coordinates. And after it does that, it uses the projection matrix to convert it to a 2D projected flat image. So since GLSL 3.3, all these functions, like if you write an OpenGL program from scratch, you kind of have to define all the matrices and how it's all left to you. So Touch does it and like provides you with this function. So if you go to the help card, you can say TDD Form. Where is it? Oh yeah, so you're gonna check GLSL Mat and write a GLSL material. So it's a different page from the top because it has all the information for the 3D stuff. And here, if I type deform, oops, not here. If I type deform, I'm just gonna type TDD Form. So it does a bunch of different things for you. It does the workspace transformation. If you're using instancing, that's where the transformation to put the instances in the correct place happen too. If you're using skinning, like bones, to deform your geometry, that's also being taken care of in TDD Form. So you can override and like kind of write your own. But if you don't want to, this is like taken care of. And then the other one, World to Approach, I think it's also in here. Blah, 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 but what it does is like, does all the operation to like use the camera metric, the perspective matrix. So if on the camera there's this view setting and I can change the field of view, and that like changes the zoom. So this is taken into account into this this function to get the correct output. And then once the geometric transformation and the like kind of flattening everything in like this this render space is, now we're back with the pixel shader, which takes care of coloring all the pixels you see on screen. And so this one is very easy. We just assign 1 to the color, so the whole thing is white, and there's no no lighting or anything. And also what it does is that, so each vertex holds attributes, and so you could say each vertex can have a color, and then this color is going to get interpolated over the different pixels. So what I can do is, if I get into this box, or maybe I just do, yeah, I'm going to take the torus again and take like, maybe simplify it a bit, do, so now it's like a pretty low-fi torus. And I'm gonna assign colors to the point. Yeah, maybe okay, just for demonstration purpose, but nice. So what I'm doing right now is generating random colors from the point positions. Yeah, and And so now if I point my sub to here, you can see I have CD 0, 1, 2, so this is like one color per for each vertex. And now the question is, oh, but this is still white. How do I get it to take colors? So the default mat, for example, I think it has built-in support for colors. Yeah, so the default constant is going to read the color attribute and use it. But here, what you need to do is to kind of write out vec for cd and set cd, maybe gonna there OCD equals cd. And then here I can do in vec for cd, and I can do color equal cd. Sorry?
Yeah, output OCD, is that one? Is it out?
Yeah, out is gonna something that goes to the next shader stage, so the fragment shader.
But then on the inside, does it need to be named OCD as well?
So CD is a built-in attribute, so it's gonna, I think any points. So here I create a new point attribute, which is called CD. And so now I can just oops. Oh yeah, so this doesn't compile.
It's got to define color.
Yeah, that's true. So I guess, yeah, I still need to nope. And out. Yeah, it says it's already declared, so.
So, but on the pixel shader side, the point in.
Yeah, it's coming from the, for the pixel shader, it's an input. So
Yeah, shouldn't it be called OCD if you're out in OCD?
oh yeah, you're totally right. Sorry about that. I don't think it matters. Oh yeah, it does. So yeah, thank you. So sorry, this is like a long demonstration. What I'm coming at is that any attribute that is stored on a vertex gets interpolated for all the pixels that kind of go in between.
So the out of pixel goes into, sorry, the out of vertex goes to pixel?
Yeah. So, okay, so now that we've seen, and so this is the pixel shader. And so all the stuff that we've done this morning, you can apply and like do in this one. So that's one way to kind of create a GLSL mat. Another way is if you create a Fong and then at the bottom of the first page, you have this output shader and you click on it and you say OK. It's going to create a GLSL mat with all the kind of code and parameters matching the Fong you have.
Do it again, sorry?
So you create a Fong, and then on the first page you do output shader. And the nice thing is, so by default, this one has Phong lighting. But if I were to kind of turn that into a constant material, so just to show you, here you see the shader to output, it says two-sided lighting. But if I were to turn that into a constant material, so I just use the constant and I click output, then it's suggesting me to do not lighting. And if you compare it, so this one, there is like, it's going to export the normal between the vertex shader and the pixel shader. But this one, for example, it doesn't do it. And so it's going to kind of customize the code based on the option you're using. So if I want to do, one last example is if I want to do texturing, for example. So I'm going to connect a noise in the color map, and then I do output shader. And so this time I get text coordinates, which are being passed between the two. So the thing is that if you like start from like a simple one, and then you like do some of your own code, and then you want more feature, you kind of have to like add them in or copy paste to like. But it's like nice to. And so one last thing with syntax is here I was just declaring out and then the name of what I was going to pass. But you can declare a structure, which is, so this is vertex, and it's, you get this brackets. Is it brackets or I never get
Curly brackets.
curly brackets. Thank you. And you have these 4 different things, and then so these 2 blocks have to match.
Oh, just between
The vertex and
the vertex
pixel.
and the pixel?
Yeah.
Not the. Oh, sorry. There's only 2.
And so,
Oh.
yeah, and that's the part where I was confused, because this one is called overt, but in the pixel they're calling it ivert. So I guess it's something to do with using a structure or not, maybe. But anyway, the 2 have to match. So for example, for this one, if I kind of get rid of the color, then it's going to give me a compiler, and it's going to say, yeah, but I want to get rid of these 2. Okay. So now the vertex compiles, the pixel shader compiles, but mismatch between shader stage means that the output of the vertex shader is different from the pixel shader, and they have to match.
Wait, the output variables, right? Not
Yeah.
Not the actual values, because it can't read the values.
Exactly.
Okay.
Just the variable it's looking for don't match.
Cool.
So in general, the vertex shader deals with geometry deformation, and the pixel shader deals with pixel colors. Any expensive operation that you can do, that you can get away with in the vertex shader, it's going to be cheaper because you're going to do them on fewer points, the vertices, and then the value get interpolated into the pixel shader, instead of doing them for every pixel in the pixel shader. So just some things to like think about. So let's see. Yeah. So that's one. Oh yeah. So one last thing I wanted to say is, so I'm gonna get rid of all that again and create Mat Phong. So in a Phong shader, what's going to be the extra thing is basically it takes surface attributes such as the normal, and then Touch has this TDD lighting function that's going to kind of compute the brightness of the pixel based on the light and the normal. So just to, if you don't know about foam lighting, so in a profile view, let's say that's the side of your torus. So here I have vertices, so it should be sorry. And so surface normal is a vector that points away from the surface. And so if you have your light, there is a directional light this way. So based on if these two vectors, based on the angle between these two vectors, that's gonna give you the intensity. So these two are the same direction, so this is gonna be super bright. But if you kind of if you do this one, and so this one is like this, and then here I have the direction is like this. But the basic idea for lighting your geometry is that it depends on the angle between the surface direction, which is called the normal, and the light direction. The second type of kind of classic lighting is specular lighting, and it's more like reflection, and it also takes into account the camera direction. But anyway, so the TD lighting function kind of and the classic way to kind of know what's the angle between these is to use that product. So that, and it's also if you have two vector, it's A point B, and what it does, it kind of projects one onto the other. So when they're perpendicular, it's going to be 0, and when they're parallel, it's going to be 1. And so the TD lighting function kind of it's building on that and a bunch of other things. Because it's doing both diffuse lighting, which is this, and the specular lighting.